Hey everyone, so I'm going to do the review sheet for your second test. Alright, so the first question says, the graph of p of x is shown to the right. What is the remainder when p of x is divided by x plus 2? When you divide something by a linear thing, so I'm dividing p of x by a linear thing, meaning that it's x to the first. When you do that, you can apply the remainder theorem. What the remainder theorem states is that if you divide, it states that if you divide by something that's linear, you can solve for the x value that goes with this, and the y value happens to be your remainder. So all I have to do to find my answer here is set my linear, my divisor, equal to 0. The reason why I'm setting it equal to 0 is because I want to have a remainder of 0. So when x equals -2, I will find that remainder that would go with the division of this polynomial by x plus 2. So if I divide by x plus 2, and I set this equal to 0, my remainder will be just the y value. So if I look at the graph, the point's right here, because you have -2, 1, 2, 3, 4. So the y value is 4, meaning my remainder is 4. Therefore, x plus 2 wouldn't be a factor because it doesn't go in evenly, because you have a remainder of 4. Factors for this example would be here, here, and here, because they cross evenly. So like a factor, for example, if you wanted something that went in evenly, would be like x, because it's x plus 0, or x minus 1, 2, 3, or x plus 1, 2, 3, 4, because this is at a -4 and this is at +3 and this is at 0. So those would be factors. But x plus 2 is not a factor because that point is not crossing the x-axis, meaning the remainder is not 0, the remainder is 4. Okay, so for the next one it says, Professor Snape gave his class the 3 mathematical rules shown below to either prove or disprove. Which of the rules can be proved for all real numbers? Now, for all real numbers means it has to work for every single number. So what you can do is actually pretty simple here because it's a multiple choice question. What you can actually do here is just plug in numbers for m and p, or x and y and a and b. And if one side equals the other, then the rule works. So I'm going to do the first rule. I'm going to use 2 and 3 for all of these. I'll make m2 and p3 first. So what I'm first going to do is plug in for the first side. So I have 2 plus 3 squared. So that's the first side. And I'm going to see if it equals 2 squared. So 2 squared plus 2 times 3 plus 3 squared. So all I'm doing is putting in 2 and 3 into the m and the p. When you plug this left side into your calculator, you will get 25. And when you plug in the right side in your calculator, you also get 25. So this rule works. So rule 1 works. I'm going to do the same exact thing, but for rule 2. So I'm going to use 2 and 3 as well. 2 will be x and 3 will be y. So my first side is 2 plus 3 cubed equal to 2 cubed plus 3 times 2 times y, which is 3. So let me just undo that. Alright, so that's 3. And plus 3 cubed. Okay, so now I'm going to plug the left side into my calculator. It gives me 125. My right side gets me 53. That is not equal, so I know that rule 2 doesn't work. And then I'm going to also use 2 and 3 for the last one for a and b and see if each side works. Okay, so I'm going to have 2 squared plus 3 squared all squared and see if that equals the other side of 2 squared minus 3 squared plus 2 times 3 times, well, it's 2 times 2 times 3 because the a comes first, but it really doesn't matter because it's commutative. And that is all squared. So the first side gets me 169, and my next side also gets me 169. So rule 3 works. So since rule 1 and rule 3 work, I get D. Now you can use any numbers that you want for this method. Because it's multiple choice, the easiest thing to do is plug in for the letters and see which side equals what. That's just like a trick to use whenever you do a multiple choice question. Alright, your next question says, write a quadratic function that is reflected over the x-axis, translated 4 units left, and shifted up 8 units. So first off, when I see quadratic, I think of my parent function y equals x squared. And for it to be reflected over the x-axis, well, the form of a quadratic is this. So what I want to do is plug in the values for a, h, and k that'll do what this is asking. So the reflection of the x-axis is actually the a value. If I want to reflect over the x-axis, I just simply need to make it negative. I don't even need to put a number. I could just put negative, really -1, but we don't need to put that there. X translated left 4 units is +4, because remember it's opposite of what you think on the inside of the parentheses. Then up 8 units is +8. So this problem asks you, given f of x equals fx cubed minus 24x squared plus 3, find f of 5. So all you have to do for this problem is replace where you see x's with a 5, because f of x is now going to become f of 5. So the first thing I'm going to do is do f of 5 equals 4 parentheses 5 to the third minus 24 parentheses 5 squared plus 3. Type that into your calculator, use your parentheses, and you'll end up getting -97. Now the next part says, what does that tell you about x minus 5 as a factor of f of x? This tells us that x minus 5 is not a factor because f of 5 does not equal 0. This is referring to the remainder theorem. The remainder theorem states when you plug in the number that goes with this factor, if you get 0, and therefore it's a factor. The reason why we plugged in 5 and not -5 was because when you set this equal to 0 and you add over 5, you actually get x equals 5, and that's why they're plugging in 5 instead of x minus 5. So on this question it says determine the quotient and remainder when 12x cubed plus 20x squared plus 11x plus 4 is divided by 3x plus 2. Express your answer as q of x plus r of x over d of x. I'll explain what this means in a second, this little section here, but for now I'm just going to divide and get my answer. So this is a long division problem, and the reason why is because there's a number in front of the x, like there's a 3 there. So I'm going to set up my long division and go for it. So remember, your 3 steps are divide, multiply, and subtract. You're going to want to divide the first term by the first term. That's always going to be the case. So 12x cubed divided by 3x will get you 4x squared. Then what you're going to do is put that on the top because that's a part of your quotient. And you're going to multiply by the outside piece. You always multiply by this piece. I'm going to distribute this in and get 12x cubed plus 8x squared. And now what I'm going to do is subtract. When you subtract, make sure you change both signs of the binomial that's there. This is going to get you 12x squared plus 11x plus 4, just dropping these guys down. I'm going to start the process all over again. Divide the first term by the same first term up here. So it'll be 12x squared divided by 3x. And that's going to get you 4x. And you're going to put that up here because, again, it's a part of your quotient. So you divided, now you multiply, again by the same thing, the divisor. We get 12x squared plus 8x. I'm going to change my signs because I'm subtracting, and these will cancel out, and I'll be left with 3x and drop down my positive 4. Then I'm going to do it all over again. Divide the first term by the first term. 3x divided by 3x will get you 1. And then again, that's part of your quotient. Put that up there. And I'm going to now multiply by my outside piece. That'll just get me 3x plus 2. And I'll subtract by changing both signs, and it'll get me a remainder of 2. So I did determine my quotient, and I got my remainder, but now they want me to write it like this. The q of x represents the quotient. The r they're talking about is the remainder, and the d of x is your divisor. So the way I'm going to write this is I'm going to write my quotient first. So 4x squared plus 4x plus 1. I'm going to add my remainder and divide it by my divisor. And that's it. The next one's factoring. One typo here. Part A should say k over that x there. Sorry. All right, so the first type of factoring that's in this question is grouping. It's grouping because this has 4 pieces. So the first thing I'm going to do is split this down the middle, and I'm going to look for a GCF out of the first 2 factors. And the GCF that I see is k squared. So I'm going to pull out a k squared, and I'll be left with k plus 5. Now I also want k plus 5 on the other side, but my issue here is that I have 2 negatives. In order to fix that, I'm going to pull out a negative 9 to make this k plus 5. These are my binomial GCFs. I'll get k plus 5, and whatever's left over goes in its own set of parentheses. Now always remember to factor completely. The second piece is dots, so my final answer is going to be k plus 5 times k plus 3 and times k minus 3. Okay. The next part, I see a binomial. So there's only 2 types of factoring in the binomial. It's either dots or cubes. In this case, I see cubes, so I know that I have cubes. Now, I always want to look for a GCF, so what I suggest you do is go into your calculator, hit math, and then hit num, and you're going to go all the way down to 9 and pick GCD. In your calculator, when you pick GCD, what you're going to do is plug in 27, 216. When you do that, you're going to see that there's a GCF of 27, which is going to make my life a little easier when I factor, because now when I factor, I'm going to have an easier type of factorization. So it's going to be h cubed plus 8g cubed. That's what you get left over when you pull out the 27. Now, hopefully it's easier to see that you do have perfect cubes. So when you have perfect cubes, you make 2 sets of parentheses, one for a binomial, so 2 things here, and one for a trinomial, so 3 things here. I'm going to bring down the 27 because it is a part of my answer. My first step is to take the cube root of each. That's going to be h and 2g. Then we write the word SOAP, S-O-A-P, and it's going to be same, opposite, always positive. To get my first term here, I will square this first term. So that's going to become h squared. To get my last term here, I will square this whole entire last term. So it'll be 4g squared. And to get my middle term, I'm going to get 2gh. I got that by multiplying these 2 things together. Okay. The next one is a binomial. So like I said before, when you have a binomial, you can really only do GCF or dots or cubes. In this case, it's very close to being, well, it is dots essentially, because we know that 4 is perfect, x squared is perfect, and 64 is perfect. But it's always good to look for a GCF. And there is a GCF here. It's 4. And when you pull out that GCF, you'll make your life a little easier, because when you pull out the GCF of 4, you end up with x squared minus 16 on the inside of the parentheses. And pulling out the GCF first is always good so you don't forget it in the end. So left with 4, and then x plus 4 times x minus 4. The next type of factoring that I see here is a trinomial. I also notice my trinomial has a number in front of it. When that happens, you make your pair of glasses. So 5 times negative 12 is negative 60. Then you want to think of factors of negative 60 that add to a negative 4. So I'll have negative 10 and positive 6. That gets to a negative 4. So I'm going to split this into 5x squared minus 10x plus 6x minus 12. And then it just turns into factor by grouping. I split this down the middle. I get 5x and x minus 2. I'm going to pull out a 6 here because that's my GCF and get x minus 2. I'm going to take my binomial GCF, which is x minus 2, and whatever's left over is 5x plus 6, and there we go. So this question has 4 terms, so I'm going to try to group by splitting it down the middle. And I'm going to think of a GCF that goes into 3y and 5. Now I'm stuck because I don't have a GCF that goes into 3y and 5. So what I'm going to have to do is rearrange the polynomial, because we know it can be factored because they're asking us to factor it. So there's a few things you could do to start this problem off. I'm going to switch these first. So I'm going to get 3y plus 15 minus 5x minus xy. Now I notice that the y is first here, so I'm going to move him over so that he's first as well. You can move around the polynomial as much as you want, but this might make our life much easier in the end. So I'd move two things around because what I wanted to happen was I wanted the y in a number and the y in a number. So I'm going to try to group again. So I'm going to split this down the middle. My GCF on this side is 3, which will be left with y plus 5. And my GCF here is x. Now, if you notice, the signs are both negative, so we're going to pull out a negative x so that we get y plus 5, just like we have on the other side. So now, since these guys are the same, I can write them as one single parenthesis, and then whatever's left over gets its own parenthesis. And that's that. Okay, the next question says, Mr. Braun sells dirt bikes. The number of dirt bikes he sells can be modeled by this polynomial. So this is the number he sells, the amount. And the average cost to make each dirt bike is this polynomial here. They want you to write a polynomial named t of x that can be used to model the total dirt bike production cost. So total cost, that's why they're using t. Now total cost is a regular form that you should know. Total cost is really just equal to the amount of units you sold times the cost of each unit. So really it's just a multiplication problem. So what you're going to do is just multiply d of x times c of x to get your t of x. So I'm going to do negative 0.3x squared plus 5x minus 4 times negative 0.01x plus 5. Okay. All I'm going to do is set up my box to multiply these two polynomials. Negative 0.3x squared plus 5x minus 4. Just be careful with multiplying these things because they are decimals. So my first thing is I'm going to multiply negative 0.01 times 0.3, negative 0.3x squared, and that's going to end up getting me a positive 0.003x cubed. Okay, so the next thing I'm going to multiply are negative 0.01 and a positive 5. That'll get me a negative 0.05x squared. Then I'm going to multiply negative 0.01 times negative 4. That'll give me a positive 0.04x. Because of the x, I can't forget about him. Then I'm multiplying negative 0.3 by 5, and then I'll get me a negative 1.5x squared. Then I'm going to multiply 5 times 5, which is 25x, and then 5 times negative 4, which is negative 20. Remember, your diagonals do combine here, and your final answer is 0.03x cubed minus 1.55x squared plus 25.04x minus 20. This is t of x, which represents the total cost of all your dirt bikes times the cost of each dirt bike. So this question asks you to divide this polynomial by x minus 2. So because this is just x minus 2 and it's not squared or anything like that, I can apply synthetic division. So I'm going to set this equal to 0. I'm going to add 2 over. I'm going to get x equals 2. So that's going to be what goes into our box. Now I'm going to take my coefficients. So 4, negative 3, 5, and negative 8. I'm going to draw my line underneath. My first step is to bring down this 4. I'm going to do 2 times 4 to get this. That gets me 8. And then I'm going to add. Negative 3 and 8 get you 5. And then 2 times 5 is 10. Add, you get 15. 2 times 15 is 30. Add, you get 22. This is my remainder. So now what I'm going to do is I'm going to go down by a power. So if you notice, my polynomial started off with x cubed. So because that's the case, I'm going to do x squared plus 5x plus 15. Now I have to add on my remainder over my divisor, and that's my final answer. This next question says when the function p of x is divided by x plus 9, the quotient is this. So they want you to go backwards on this problem. There's more than one way to do this, but going backwards in my mind means multiply. So what I'm going to do is I'm going to multiply these two guys so that I can find p of x, because I'm going to do the opposite of division. Now, I think what's easiest for you guys to try would be box method, but the only thing is that we have to do the remainder last, okay? Because that's what's left over. It needs to be added onto the polynomial. So I'm going to do x cubed, 4x squared, 3x, 9x squared, 36x, and 27. So I'm going to combine my like terms. X cubed plus 4, 9 and 4 make 13 x squared, and then 36 and 3 make 39 x plus 27. Now what I'm going to do is I'm going to add on this remainder of negative 7, because that's what's left over with this polynomial. These guys are going to combine, and p of x is now x cubed plus 3x squared, 13x squared plus 39, and then 27 plus negative 7 is 20. Now if you want to know you got the right polynomial, plug in negative 9 in for all the x's, because this is x plus 9, and you should get out negative 7. That's how I checked myself. Again, this is only one way of many to do this problem, so if you want to learn a different way, I can teach you more at Extra Help, but I think this is the simplest way. The next question says write the expression in simplest radical form. So the first thing about this is you want to break up the radical as best as you can. So I'm going to rewrite the 5 because he's outside. I'm going to split 18 up into a perfect square and a non-perfect square. The highest perfect square inside of 18 is 9, so it'll be radical 9, radical 2. X to the fourth. Remember, you need to divide by 2 because there's an index of 2 that you do not see there. So 4 does divide by 2, so I can keep it in the house there. X to the seventh, though, has an issue. 7 does not divide by 2. So when this happens, when you have an odd power inside of a square root, you split that y to the seventh into something even and something odd. And you always want to go for the first even number below 7. So that's going to split up into y to the sixth and y to the first. Okay? So now I'm going to simplify my radicals. 5 will just stay. Radical 9 becomes 3. Radical 2 has to stay inside the house. He's not perfect. But radical x to the fourth becomes x squared, and radical y to the sixth becomes y cubed, because the square roots of those, you half the powers. And the square root of y stays the square root of y, because you can't half 1. So now I'm just going to bring things together. So I see a 5 times a 3, which gets me 15. Anything that's not a radical will be pulled to the front. And these guys are in radicals, so they combine to the same radical. So that's my answer. This question is asking you to multiply this x in, but the problem is that you have this squared. So what you need to do is you need to write this out twice, and then you need to box method it. And then we'll worry about the x later on. Okay, so I'm going to have 3 minus 4 rad 2, and then 3 minus 4 rad 2. Box methoding that, we get 9 minus 12 rad 2, minus 12 rad 2, and then 16 rad 4. Okay, I'm going to combine my like terms, so I get negative 24 rad 2, and then this becomes positive 16 times 2, because the square root of 4 is 2. I'm going to keep simplifying, so 9 minus 24 rad 2, 16 times 2 is 32. Now I'm going to do 9 plus 32, and 9 plus 32 will get you 41. Yep, so 41 minus 24 rad 2. But we still have to bring this x in. We don't want to forget about him. So our last step to this problem is to distribute him in and we'll get 41x minus 24x rad 2. Now, if you're not sure if you did this problem right, type this whole thing into your calculator with the x, and then type in the problem into your calculator, like the original, and you should get the same like weird decimal to check yourself. Okay, this one's a division problem. So what I usually do is I think about the insides, and I draw my two radicals. So I think to myself, can 5 divide by 80? And that is true. So if you go to your calculator and just type in 5 over 80, it reduces to 1 over 16. So that's what I have for my numbers right now. And they're still inside the radical, but at least we simplified them. The x over x cubes. Now, there's more than one way to think about it, but theoretically, there's only one x up here and 3 x's down here. So what happens is you can cancel this one out and this one out. You're left with 2x squareds on the, well, 2 x's on the bottom, which becomes x squared. Okay. And then do the same thing with the z's. So z cubed over z, and same idea. There are 3 z's on top and 1 z on bottom, which cancels this out, which means there's only 2 z's left on top. Okay, so now we're going to, this is a 2, I'm sorry. Now we're going to simplify. So I have 2, the square root of 1 is 1, and the square root of z squared is z. So I get 2 times 1z. And the square root of 16 is 4, and the square root of x squared is x, so that comes out. And the last thing I can do right now is I can divide 2 and 4, and that results in 1/2. So my answer becomes z over 2x. I mean, you could put the 1 here, but you really don't need to do that. It's really just z over 2x. All right, last question is an adding radicals question. So it's really up to you how you want to start this, but the goal is that you get the same radical on the inside, and then you're able to combine them. But right now we can't combine them because they have different radicals. So what we want to do is simplify them. Sometimes it's good to do one at a time, but it's really up to you how you want to do it. So I'm going to deal with this one first. 45 will break up into 9 and 5, which results in 3 rad 5. Okay, the y squared comes straight out as a y, so that's done, so that's good. So what's left over right now is 3y rad 5. And the x cubed is where you got to start to work. So you got to think, how many times does 3 go into 2? Okay, so remember we talked about doing power over root. This is not divide evenly, so what we have to do is do some long division. So 2 goes into 3 once with 1 left over, which means that 1x comes out and 1x stays in. So that's simplified now. We have 3xy rad 5x minus. Now this x is on the outside, so he's just going to stay out there, this guy right here. He's going to keep staying on the outside. So I just brought him down to the bottom so that we have him ready to go. Okay, now I'm going to do the same thing with 20. That's 4 and 5, which becomes 2 rad 5, which means I have 2 on the outside and a 5 on the inside. This x is done. You can't divide 1 by 2 because the power over root thing. So that's going to stay on the inside with that 5. And then y to 2 divided by 2, well, that becomes just y, like how this one did. So that comes out. And now, last but not least, we got to combine these because we finally have the same thing, which means that like these guys both have 5x, rad 5x, and they both have xy. So they're like terms. So all I have to do is add 3 minus 2, and I get my answer. And 3 minus 2 is 1, so I'm left with xy rad 5x. I hope this video helped you guys. If you need more help, please come to Extra Help. I'd be more than happy to go over anything that you'd like me to go over. And have a great night.